Now we get to solve a problem that applies to you. We have a 20-year-old college student who saves $5 a day and puts it into a drawer until the end of the year. Then she puts the $1,825 total into a brokerage account, which is expected to earn 8% a year. How much will she have when she is 65 years old? N is going to be equal to 65 minus 20, which equals 45 years. I/YR is equal to 8. Present value is 0, and payment is the amount that she puts back each year, which is $1,825. Then hit the compute button and future value. The answer of $705,373 will appear. And this just assumes that she is really saving 5 times 30 or just $150 a month. Obviously, she should be able to save more as she gets a job and gets raises over time. If you all would do this, you will be big-time millionaires when you retire. This is all because you have lots of time to earn compound interest. Dave Ramsey calls compound interest a mathematical explosion. To illustrate this problem, I make sure that I'm in end mode. Then I type 45 n 8 I/Y 0 present value 1825 negative payment, and then compute future value. And you see that the answer is $705,373. Now let's look at a sad example. You waited until you were 40 years old to start this investment process. Since you only have 25 years until you are 65, you only end up receiving $133,418 if you do the same thing. This is much less than the $705,000 that we had on the previous slide. So it definitely pays to start saving early. If we wanted to figure out how much extra the 40-year-old would have to deposit each of her 25 years to catch up to the future value of the 20-year-old, we can solve for the payment key. Just put in the desired future value of $705,373 and then solve for payment, which you'll see that she'll have to deposit $9,648.64 per year. This means you have to deposit a little over 5 times as much as the 20-year-old to catch up if you are the 40-year-old. To illustrate this one, I would put in 25 n 8 I 0 present value 705,373 as the future value and compute payment. And so I get the $9,648.64. Now we turn to uneven cash flow streams. As you can see on this timeline, most of the cash flows are different, 100 to 300 to negative 50. We cannot use the payment key anymore on the calculator because this is only for constant cash flows. The payment key, well, like I said, is only for constant cash flows. So to reiterate that, what the PowerPoint slide shows is a long process of computing the present value for each of the future cash flows and then summing up these values to find the final price or value of this stream of cash flows. But we will learn a much easier way in the next slide. To solve for the present value of an uneven cash flow stream on the calculator, we will perform the following steps. First, we have to clear out the cash flow register. The cash flow button is right here on the calculator. So if I click it, I need to clear it out. So I hit second, clear work. And that should clear out everything in here. If I hit the down arrow, there shouldn't be anything there. It starts out at cash flow 0. So since cash flow 0, there was nothing there, I hit a 0. I have to hit the enter button and arrow down. Then it says, what's the cash flow at time 1? And I enter 100, and I have to hit enter to make that number stay there, and then arrow down. And then it says frequency of cash flow at time 1. That's what FO1 means. And the frequency is that $100 happens only one time. So we just leave that at 1, and it's a good idea to always leave the frequency of your cash flows at 1. Cash flow 2 was 300. Enter and down, and we're going to leave the frequency at 1 just so we could stay in the same numbering system with the cash flow numbers here. So I'll leave the frequency at 1. Cash flow 3 was 300. Enter, down, frequency 1. And then cash flow 4 is a 50, but it's negative. So make sure you enter any negative numbers. Then we will go, the next part of this process is that you have to go to the NPV button. And it asks for the interest rate, and the interest rate was 4. So you have to hit 4 and enter. And you can see this enter up here is stated whenever it's trying to remind you that you should hit the enter button to make numbers stay. And then I arrow down, and this is for NPV, and then it's telling me up here to compute. So I hit compute, and I get $597.48, just like they got on the previous slide. Now, whenever the interest rate is compounded more often, for example, semi-annual or monthly, you earn interest on interest faster. Therefore, you will have a greater future value. The example here shows the difference between annual and semi-annual compounding for a $100 investment at 4% interest for 3 years. This one is compounded annually, and this one is compounded semi-annually. And you can see that your future value is $112.62 for the one compounded semi-annually, and only $112.49 for the one compounded annually. Now this is a very short amount of time with a very low interest rate, so you don't see a big difference here. You just see that semi-annual gives you a bigger number than annual. If we had a larger amount of money, like $1 million at 8% interest for 20 years, we would see a much bigger difference in these numbers, and it would be more exciting than this.